review some log properties, things that you probably learned at one time and maybe still remember or maybe not, and that's okay. Just to make sure we're all on the same page. So there's a few log properties that I want you to write down here. And so one of the log properties that we have, and again, these are all based on the fact that logs are inverses of exponential functions. So one of the log properties you can have is that if you have log of A times B, if you have a product within that log, you can expand that to say that's log of A plus log of B. And again, that comes from the fact that when you are multiplying exponential functions and they have the same base, then you add the exponent. So we sort of are undoing that with this log property. Okay, so that's one property you should know. Now, its reverse would be, and make this kind of Halloween-y, right? So if you have log of A divided by B, that's the same thing as log of A minus log of B, right? So that's another property you should know. Another one that we've talked about, and I'm using log very liberally, it could be any base, right? Log of 1 in any base is always equal to 0, where log of 0 does not exist. And that helped us graph our functions, right? That was our vertical asymptote. Okay. What else? Log of, let's say, A to the x power is equal to, well, that x can come in front, x times log of A. Okay, so it's another property we should know. Sorry, wrong tab. There we go. Next property. So if you have log base B of A, and you want to rewrite that, you can rewrite that as common log, or like log of A divided by log of B. You could also write that as natural log of A divided by natural log of B, or really any base for that matter. But we pick log or natural log simply because those are the two that are most calculator ready. Okay, and then the last one that comes up every once in a while is that if you have, let's say, log base B to some power of A to that same power. In other words, like maybe like both B and A are both squares or both cubes. Because of all of the properties above, because you could bring those, because you could rewrite that as a quotient and then pull out the exponent, that is equivalent to just log base B of A. So that one comes up every once in a while. So how do we usually see these? And you probably saw these last year. You're not really solving for logs. You're just kind of manipulating them using the properties. So a very classic kind of problem is something like this, where you are trying to express things in terms of, like, in this case, x and y. So I'm looking at this natural log of 12, and if you know how to do this already, you could always pause the video and do them, and then fast forward to the end and see. But 12 is the same thing as 2 squared, which is 4 times 3. So because that's a product within the log, I can write that as natural log of 2 squared plus the natural log of 3. And because this 2 can come out front as a property, I say that's 2 natural log of 2 plus natural log of 3. And now I know what natural log of 2 is equivalent to, and natural log of 3 is equivalent to. So I can say this is 2x plus y. Okay, so that's kind of the idea here. And all of these should be able to be manipulated with a 2 and a 3. So then we look at the next one. It says natural log of 1.5. Well, 1.5, if you think about that as a fraction, is 3 divided by 2. Because that's a quotient, I could say that's natural log of 3 minus the natural log of 2. And then I know what natural log of 3 is. I know what natural log of 2 is in terms of our variables. So we could say it's y minus x. Okay, log base 3 of 2. So this is using that change of base formula. So I could say that's the natural log of 2 divided by the natural log of 3. Now, I certainly could have said log, like common log, and it would have been correct to say that, but it doesn't help me simplify it. I want to choose natural log because that was sort of like what was given. And then we just say that's x divided by y. Okay. Log base 6 of 8, same starting point, right? We're going to rewrite that. So that's natural log of 8 divided by natural log of 6. And then I think about 8, that's 2 cubed. So natural log of 2 to the third power. And then 6 is the same thing as 2 times 3. So now what I can think about, that 3 can pop in front. So it's 3 natural log of 2 divided by natural log of 2 plus the natural log of 3 if I break up that product. And so then that would equal, now I can go ahead and change pen colors. I guess I started that trend here. That equals 3 times x divided by x plus y. Excellent. Okay. Maybe I should slide this over here just so I have it. Oh, yeah, that's great. Okay, log base 27 of 0.5. So thinking about, again, just doing a rewrite in terms of change of base. So thinking about that's natural log of 0.5 divided by natural log of 27. So like right away, I know that 27 is 3 cubed. So I could say that's 3 natural log of 3, and kind of condensing some steps or thinking out loud and then writing down, because 27 is right 3 cubes, so that 3 could have come in front. So that's how I got to this step right here. Now 0.5 is 1/2, but you could also think about that 1 divided by 2, or natural log of 2 to the -1, and that -1 can come out in front, and so now I've got negative natural log of 2 divided by 3 natural log of 3. Well, then that would be negative x divided by 3y. Make sure that 3 is in the denominator. Okay. Now, some of you might have said, well, wait a minute, 0.5 is 1 divided by 2. So why couldn't you, as an alternative, why couldn't you think of this as natural log of 1/2? And since that's a quotient, you could say it's natural log of 1 minus the natural log. Oops, can't see. Natural log of 1 minus the natural log of 2. And you're absolutely right, because natural log of 1 is 0. So then you just get minus natural log of 2. So it's equivalent. So you can think that way, absolutely. Oh, there we go. All right. So then, and that might be the way to go too. Think about this 1/6, right? Like we could think about that as, well, that's natural log of 1 minus natural log of 6. And we already knew that that's a 0 minus, and then natural log of 6 is 2 times 3. So I'm going to put that in parentheses. There it is. Because that's, 6 is 2 times 3. So I'm subtracting that quantity. So then it's the opposite of x plus y, or you could distribute. So it's negative x minus y, which is excellent. Okay. So again, properties and examples. So then what I'm going to do is, I'm going to work through everything else on this page in the next video. So if you want to try to solve them and then check at the end of that video, be my guest, because ultimately you need to know how to simplify and practice these certain log properties.